Which statement about the reactions of halogens with halide ions is correct? A. I2 aqueous can oxidize Br- aqueous. B. Cl2 aqueous can reduce Br- aqueous. C. Br- aqueous can reduce Cl2 aqueous. Or D. Cl- aqueous can oxidize I2 aqueous. In order to answer this question, we need two pieces of information. Firstly, we need the oxidizing strength of our halogens. So the strongest oxidizing halogen would be fluorine, and then it goes down as you move down the group. So we have chlorine, then bromine, and then finally iodine. Then we need the reducing strength of our halide ions. So this is going to have the opposite trend, and we're going to have I- as our strongest reducing strength halide ion, then a bromide ion, then a chloride ion, and then a fluoride ion. Using this information, we can create a table where we have our fluorine, chlorine, bromine, and iodine, and then we've got our halide ions. So we've got a fluoride ion, a chloride ion, a bromide ion, and an iodide ion. So the halogen will not react with its halide ion, so we can fill this out in the table as shown. Then if we work down our fluorine, then we're going to have our fluorine react with each of these halide ions. So we're going to have F2 plus 2Cl minus goes to Cl2 plus 2F minus. Then we're going to have F2 plus 2Br minus goes to 2F minus plus Br2. Then we're going to have F2 plus 2I minus goes to I2 plus 2F minus. Now let's fill out the rest of the table. So chlorine reacting with a fluoride ion. Fluoride ions have the weakest reducing strength, so it's very unlikely that this is going to react and reduce the chlorine to chloride ions, so we can mark this as a no reaction. This is the same for fluoride ions across the rest of the table. They're not going to react with bromine or iodine because they have the weakest reducing strength, and the oxidizing strength of chlorine, bromine, and iodine is weaker than that of fluorine. So again, they're not going to oxidize the fluoride ion. Filling out the rest of the chlorine table, chlorine will react with bromide ions, and it will produce the equation Cl2 plus 2Br minus goes to Br2 plus 2Cl minus. And chlorine will also react with iodide ions to produce Cl2 plus 2I minus goes to 2Cl minus plus I2. Let's now continue to complete the table. Bromine does not react with bromide ions, so it makes sense that something with a weaker reducing strength than a bromide ion, such as a chloride ion, would also not react. So we're going to have no reaction here. And this same principle will be applied to iodine and chloride ions and bromide ions. There will be no reaction. So then we just need to complete the last equation in this table. So we would have Br2 plus 2I minus goes to 2Br minus plus I2. Now let's use our table to work out the correct answer. A. Iodine can oxidize bromide ions. We know from this table this cannot happen, so A cannot be our answer. B. Chlorine can reduce bromide ions. Chlorine and bromine do have a reaction, so chlorine and bromide ions, but what's happening is that chlorine is oxidizing bromide ions, not reducing them. So B cannot be our answer. C. Bromide ions can reduce chlorine. Well, this is another way of saying that chlorine is oxidizing bromide ions by saying that bromide ions are reducing chlorine. So this is actually true. Then D. Chloride ions can oxidize iodine. Well, chloride ions and iodine do not have a reaction, so this cannot be true. Therefore, our answer is C, and to get the mark for this question, you need to write C in the answer box provided.